Hey there, gang. Mr. Spencer here. We are getting to the most important part of everything that we've been talking about when it comes to setting up experiments. And that's when we've taken all the data that we've collected and try to make sense out of it. So what we need to do is remember that that data that we're collecting during that experiment, the reason we're doing that, it's helping us to make predictions. It's helping us to figure out an answer to that question that we've been researching. So let's use an example here. Let's say that we want to figure out how does the number of marbles affect the total mass of a container. So you've got this container here, you're adding marbles to it, you want to see what's happening to that total mass. Well, you guys have been doing this like crazy. If that's our question, then we know that our independent variable is going to be the thing that we can manipulate. Okay, it's going to be, in this case, the thing that we can mess with is the number of marbles. Our dependent variable is going to be the mass. And when we write our title as dependent versus independent, it's going to be like total mass of the container versus the number of marbles. Now, this is an example of someone who did this experiment, the stuff that they collected. You'll notice that they did multiple trials and they found the average. Now, what we're going to do here is we are going to use that to make a nice little graph for us. And when we do that, we don't graph the trials, we just graph the average. So if I go and create a graph that plots the average mass the total average mass versus the number of marbles, this is what I get. All right. Now, what we want to do in terms of being able to use this information to be able to make some sense out of it is we want to create a line of best fit. Now, if I look at this, if I squint really hard and look at those dots, it seems like it's pretty much a straight line. All right. And if you were to be able to draw a line that goes through the middle-ish of all of these dots, you would get what's called a line of best fit. And what that line of best fit does is it shows us a general relationship between those two variables. So what we see is as you increase the number of marbles, the total mass also increases. But we want to be a little more specific with that. So let's take a look at this. One of the things that we want to be able to do, once again, is to be able to make predictions using this line. So let's say that I have 6 marbles, okay? And I want to use this container I want to use this graph to be able to figure out what's the mass of 6 marbles on average. Well, what I'm going to do is I'm going to look down here along the bottom. I'm going to find where it says 6 marbles. And because these are XY coordinates, I can go and I can say, okay, I'm going to go and follow up from number 6 marbles up till I hit the line, and then I'm going to go over to the left here and find the spot where it has the total mass. And in this case, okay, I've got about 64-ish grams. So on average, I can figure out what it is if I have 6 marbles, what the total mass is. Now we can also go the other way. All right. Let's say I have 100. I want to know if I have a container with a mass of, let's say, 100 grams. How many marbles are probably in it? Well, once again, because these are XY coordinates, they match up, and I can go over there on the left, find the spot where it says that there's 100 grams, follow that over until we get to the line, and then follow it down. And we look here, and if you're at about 100 grams, you're probably going to have around 9 marbles there. All right, so that's one of those easy ways of being able to use that line of best fit or use the data to be able to make some predictions. Something else we want to be able to do is make some calculations. Now, I want you to think back to your math classes when you talked about the equation of a line. And this example that we used is pretty basic. All right. And we know from our math classes that if you have a straight line, Right? The equation for that line is this y equals mx plus b. And when we're talking about that, the y in y equals mx plus b, that's talking about the y value. The m is the slope, the x is the x value, and the b is what's called the y-intercept. So let's go through those because we want to know not just y equals mx plus b, but we want to know what does this mean in terms of our actual graph that we have here in front of us. Well, if we look at this particular graph that we've just put together, and we want to figure out, okay, what does the y represent in y equals mx plus b? We'll take a look over here on our y-axis, on the vertical axis. Well, that's total mass. And if we want to think about this in terms of x, right, what does the x in y equals mx plus b mean? Well, that's our number of marbles. Also, in y equals mx plus b, when we look at that m, okay, m stands for slope. And what we have here when we're trying to figure out slope is that's just the ratio of change. And when we're talking about this, we're talking about the ratio of change between mass and marbles. Now, once again, thinking back to your math classes, if I'm calculating the slope, I want to find the change in mass. Well, where's mass? Right? That's here along the vertical axis, the y. So if I just pick 2 points, and it can be anywhere because it's a straight line, they're all the same. So let's say I'm going to take 2 marbles, and on average, 2 marbles have a total mass, or a container with 2 marbles have a total mass of like 64.8 grams. And then I'll take another one here with 8 marbles and 93.5 grams. Well, with that slope, how does it change? Okay, how does the mass change? Well, if I take 93 grams minus 64.8 grams, that's going to give me 28.7. And then we want to change how the run goes, okay, the side to side. So that's going to be 8 marbles minus 2 marbles, so it gives us 6 marbles. Well, when I take 28.7 grams divided by 6 marbles, what that gives us is 4.8 grams per marble. Well, what does that mean? Well, what that's saying is that's our average mass of the marbles. So each marble has about 4.8 grams to it. The next thing we want to look at in this y equals mx plus b is this b, okay, which is the y-intercept. Now, the y-intercept is the spot where the line crosses the y-axis. But let's think about this once again in terms of what does this really mean for our graph. Well, if I take a look here, the line crosses right here at about 54.1 grams. Well, also, if I look here along the x-axis, the horizontal axis, I see that my marbles are 0. So really what this is telling us, this y-intercept, is that when we have a container with 0 marbles in it, it's going to have a mass of 54.1 grams. Now, let's use this idea, once again, of y equals mx plus b, figure out what that means for what we call our real-world equation. So we know that y equals mx plus b, y is the y value, m is the slope, x is the x value, and b is the y-intercept. So once again, if we think about what that means on our graph, well, the y value, that's going to be our total mass. Our slope, we've already calculated that, so that's going to be 4.8 grams per marble. Our x value, okay, that's the number of marbles, and our y-intercept is that mass of an empty container right over here. So what we can do is we can take that y equals mx plus b and turn it into a real-world equation. So if I look at this, instead of y equals mx plus b, what this really means is that our total mass can be found by taking that average mass per marble of 4.8 grams per marble, multiplying it by the number of marbles, and then adding the mass of the empty container. So we can use that equation to help us extrapolate a little bit, kind of go beyond what our graph has. And so let's use this equation to figure out what would be the average mass of a container that has 13 marbles in it. It's not easy, or we can't really go in there and find 13 along the x and then go up and up and over. So let's use this equation. Well, all I'm going to do is I'm going to take this y equals mx plus b. I know the real world equation for that is total mass is going to be equal to 4.8 grams per marble times the number of marbles times the mass of the empty container. And I'm just going to substitute in there for the number of marbles, 13. So what I have is the mass is going to be the 4.8 grams per marble times 13 marbles times 54.1 grams. And what I end up with is an answer of 116.5 grams. We can also go the other way. It takes a little bit of algebra to do it, but what if we wanted to figure out how many marbles are most likely in a container with a total mass of 150 grams? Well, if I'm looking at that, okay, 150 grams, that is my total mass. So I'm going to take that same equation that we've been using, the total mass is equal to 4.8 grams per marble times the number of marbles plus the mass of the empty container. And now I have, instead of having the number of marbles, I have my total mass. So I'm just going to substitute 150 grams in there. And now I'm going to solve for the number of marbles. So this is my lovely handwriting here. Hopefully it makes sense. But like I said, I'm going to solve for this number of marbles using a little bit of algebra. So I look here. I want to get number of marbles all by itself. So I'm going to take 54.1 grams, subtract it from each side. I end up with 95.9 grams equaling 4.8 grams per marble times the number of marbles. If I want to get number of marbles all by itself, I'm going to divide each side by 4.8 grams per marble. And what I end up with is 20 marbles. So I know that was fast. So if you have any questions, please let me know and we'll get this all figured out. Thanks, gang.